I'm just going to summarize something quickly here, because this is a lot of grade 12. So we just learned what we call rationals. And a rational is a fraction. Okay, and what was the big idea with fractions? What's the thing we can never ever do with a fraction? We cannot divide by 0. So now we're going to learn radicals, which are roots. Radicals are roots. What do you think the big idea is with roots? So just like rationals, we can't divide by 0. Roots, we can't do what?
Negative.
We can't square root negative numbers. Do you get the big picture? Those two ideas put together a lot of stuff going into grade 12. Okay, so in rational fraction, you can't divide by 0. Radicals are roots. You can't square root a negative value. Okay, so the first thing that is on here is a restriction on the variable. Okay, so x has to be what here? So, great, yeah, we're going to use an inequality. You have to be greater than 7, but what else could you be, though? You could be equal to 7. Because 7 subtract 7 is 0. Can I root 0? Yes. Okay, just making sure that this doesn't go negative. So what keeps this positive or 0? So for me, I always think about, well, what makes it 0? Negative 5 makes it 0. And what do you have to be? Do you want to be bigger than that number? Smaller than that number? You want to be bigger or equal to it?
Why can't you be small?
So pick me a number that's smaller, just random number. That's negative 6. So negative 6 plus 5 is negative 1. And then what happens to square root that? Can't. Yep. Okay, what makes this 0? If x was 0. And then what do? I need to be greater than it or equal to it.
Wait, but you can't square root a negative, so why is it?
You can't square root a negative. You can square root 0 and any positive number.
Why is it
Which,
number 2?
number 2?
Make it negative 4 because it makes it 0.
Negative 5 plus 5 is 0, and I can square root that. I can, anything bigger, so like negative 4 is bigger. Negative 4 plus 5 is 1. I can square root that. Am I answering your question if I'm explaining a few examples?
Yeah. So are just all the restrictions bigger or equal?
No, not the next one. Okay, here, what makes this 0? An 8, because 8 minus 8 is 0. But this time, I actually want to be less than or equal to 8. So think about numbers. So something less than 8, like 6, 8 minus 6 is 2. And I can square root that. If you go above 8, so pick a number bigger than 8, 10. 8 minus 10 is now negative 2. Can't square root that. So here's what you can do if you get kind of stuck. The first thing is figure out where it equals 0 and write that number. And if you're confused about which way to write it, just plug in a random number that's either bigger or smaller. And does it work or not work? Okay? Okay, so that's called restrictions. You might also see me writing this in the answer key, but I actually don't know why I did this. I might write something like this: x cannot be greater than 8. That's the same thing. If you're smaller or equal to 8, x cannot be greater than 8. Does that make sense? It's the same thing.
So if the number is before the x, then it's smaller, and if the number is after the x, it's bigger.
Well, this is just different because I'm subtracting the x values, so I don't want to subtract something bigger than the 8 because now I'm subtracting too much and making it negative, right? But yeah, like I said, just pick the 8 and then pick like something above it and pick something below it and then see like what happens when you plug it in, right? So then I went like this, 10 minus 8, ooh, didn't work. 8 minus 6, or sorry, before 8 minus 10 didn't work, but 8 minus 6 is 2, so that works. So now I know I'm less. Yeah. Okay, a lot of this stuff is from grade 10, so some of it might be recapping for you. When you're doing radicals, you have to collect like terms, so it'd be like me adding x's with x's. So I can add root 3's with root 3's because they're similar to each other. So here says 2 root 3 subtract root 3 means I have 1 root 3. And then here it says I had 6 root 7's plus 2 more root 7's. So now I have 8 root 7's. So it's a like term system. Okay, so if I take that to this, I can put those together because they're root 5's and more root 5's. So 4 root 5's, 3 root 5's makes 7 root 5's. And then I can do this together. 10 root 7's minus 2 root 7's is 8 root 7. And then there's just something there because I can't put it with anything, right? Okay, so does that make sense? Like terms. Okay, multiplying radicals. So root 11 times root 3 is root 33. Okay, so the next one, I need you to compartmentalize this. Whole number parts, radical parts. Do not mix. Okay, so whole number, 2 times 4 is the whole number 8. Kind of I put that out front. Root 3, root 6 makes root 18. So now I put them into compartments, okay? Okay, so this, what are all the whole numbers going to be together? So there's a 5 out front. This technically would have a 1 in the front. So 5. Radical, so there's a radical 7, radical 8. So root 56. And number 4, so the front, that makes 6 in the front. And root 10 makes root 100. And I'm going to change that because I can. Well, what is the square root of 100? 10. That's a whole number now. That's a whole number. So now I can put whole numbers together.
So if you can square root it, then you can...
Yeah, that you can square root it to change it into that whole number. Okay, so the next part is for sure something I know that we did in grade 10. But just to refresh your memory, can you give me all the perfect squares? So like 1, 4, 9, 16. Go ahead. See how fast you are. Okay, so these perfect squares are numbers you kind of have to have memorized, okay? Recognizing the perfect squares. Breaking down a radical. So what I'm going to do is I'm going to think about a perfect square, 32 is divisible by, and I actually specifically want to pick the largest perfect square I could divide it by. 32 is divisible by, did you get any of these numbers that it could divide by? What is 32 divisible by? Anything on this list?
4.
It's divisible by 4, that's right, but I'm not going to pick 4 because it's also divisible by 16, which I'm going to always try to pick the biggest one. If I don't, I will have to do this process doubled. Okay? So trying to pick the biggest one. Okay, so what is the same thing as writing 32? Is that true? 16 times 2 is 32. Therefore, root 16 times root 2 is root 32. And then, what is the square root of 16? 4 root 2. Do you remember something like that from grade 10? This was called a whole radical, and now it's a mixed, because it's got the mixed part. It's got a whole thing and a... Okay, 300. Do you have something to divide 300 by on this list? 100. So 100 times 3. So we're working through radicals. So root 100, root 3. And then what is the square root of 100? 10 root 3. Okay, so this one, we're going to do the 20. So what kind of number am I dividing 20 by? 5 times 4. Okay, personally, I like to write the perfect square first. So instead of writing the 5 times the 4, I like to do the 4 times the 5. It's not a big deal, but... Okay, that's 6 in the front. Needs to come along for the ride. Then what am I doing? I'm going to change the square root of 4 to a whole number 2. I also have a whole number 6, and I also have a radical 5. So my final on this would be 12 root 5. Okay, shall I let you try the last one on your own and see if you can get it? Think about what you can divide 75 by. Obviously something on this list. Okay, so I picked 25 times 3 to get to 75, then knowing that root 25 would break down to a 5, connecting it to that with a 10. That worked out? Okay, so here's an example of your test question for this. This is something I do on your test. Okay, so let's start with the 20. We just did it, right, above. Root 4, root 5. The 4, root 4 breaks down to a 2, causing a 6. minus in the front, right? Okay, 48 is divisible by 16. Is it 16 times 3? 16 times 3 is 48. Be careful, if you had picked a 4, you would have got 4 and 12, but the 12 would have been able to also break down by 4, so you would have had to like repeat that whole thing twice. What did you get on that part? 20 root 3?
Wait,
Where? This guy?
yeah,
This guy? 16 times 3 is 48, right?
yeah.
And then the square root of 16 can turn into a 4. And then I can connect the 4 with the other 5 in the front. Yeah, they're timesed. Right there, they're timesing. Okay, 45. Did you find something good for that one? I'm going to pick 9 times 5. Is that what you did? And then the root 9 can change to a 3, making 18 root 5. And the square root of 12. What could I divide 12 by? 4. Okay, you're not done, because now what do you need to do? Collect like terms. So root 5s, I have 6, and then I have minus 18. So now I have minus 12 of those root 5s. I had 20 root 3s over here and 2 more root 3s. Do we remember that skill from grade 10? That breakdown, something looks familiar maybe at least? Okay, a little bit more and then we're done. Okay, so this is nothing new. You just have to make sure you're following it properly. So if I do some multiplying, you're just doing the same skill, but adding in all this foiling kind of stuff, you know. So here, if I have one thing times 2, I'm just doing what I call a distribution. Okay, so I'm going to compartments, whole number, radical part, whole part, radical part. So this would become 8 root 15. Do you see that? 8 whole number part, root 15 radical part. The next will be minus 4 root 21. Minus 4 is the front stuff. 21 is the root stuff. Okay, so you can never mix a whole part in front with a radical number. That's not what you're doing. Okay, go ahead on your own, number 2. Same thing. Can you distribute that? Whole number, radical number. Okay, so I got an 8 root 70. And here I got a 10 out front root 49. I would not leave this. You would get deductions on your test because I haven't simplified it. Because what could I do? I could do something there. The root of 49 is 7. And guess what else I can do? I can connect the 7 to the 10 now because they're both whole numbers, right? This could be tricky for people because they see a root 70 and a 70, but those have no connections with each other. Right? You can't combine them. That's not the same thing. Okay, so number 3 is a division. Do you know how you distribute a multiplication? It's the same thing. You have to distribute the division. So you have to take this divided, this divided, this divided. Just like how you times that and times that, you're doing the same thing with division. So here we go. 11 divided by 2 is the whole number, which I can't really do. So I'm going to just leave it. 11 divided by 2. Root 33 root 3 makes root 11. Number 2, we have an 8 divided by 2, so that puts us at a 4. Root 12 root 3 divides to be root 4. And the last one, minus 16 and 2 would make a minus 8. Root 27 root 3 would divide to be root 9. Not going to leave this one alone. It's not done. So what kinds of things could I do here? Well, I can change the square root of 4. And I can change the square root of 9. Okay, so this one, sorry, we're done. Is that one good though? Otherwise people are matching that? Okay. Okay, what do you think I have to do with the process when two things are multiplied by two things? FOIL, thank you, good job. I have to FOIL, so you gotta do all those things. So, just following it properly, making sure you're doing whole number, radical numbers. So the first is gonna be 10 root 21. Do you see that? There's the 10 out front, root 21. Outsides. So this is a whole number 2. So we only can put it with the other whole number. So this would make a 4 root 3. You see that part of it? It's just a 4 because it's the whole number part. Insides. So the 8 and the 5 can be together. So 4D root 7. And then the last is 16. And that's it for that one because root 21, root 3, root 7, can't do anything more. Okay, FOIL. Okay, so I get 25 in the front and a root 9. Outsides, I get a minus 5 and a root 21. Insides, I get a 5 root 21. Last is a minus sign, and then radical 49. Okay, what happens when you have a minus 5 root 21 and a plus 5 root 21? They would make 0. Here it looks like I can change a root 9 to a whole number 3, which means I can connect it to the whole number in the front. So 75. And then at the end here, the root 49 can change to that. Okay, we're going to learn this. This is a special thing. This is called conjugate. Those are called conjugates of each other. So what's the definition of a conjugate? Do you notice how in the brackets, the bracket parts are the same except plus minus? So you know what this is the same kind of idea as? Difference of squares. What happens to the difference of squares? You never have the middle part. Because what's going to happen? They're always going to cancel. So from now on, when you see conjugates, you can FLU. And I say that all the time. FLU it. Don't FOIL it. FLU it. Because of that. We know, I mean, if you FOIL it, you're just going to do extra work and then they're just going to cancel. And that's fine. Okay, so we're going to learn more about conjugates later, but recognizing it the exact same with a plus and a minus. Okay, the last one. When you have a binomial squared, this is a big deal in math. Mistakes often. I'm not squaring each thing individually. I'm squaring the unit. So what does math look like if you square a whole chunk? Squaring means repeated twice. So do not square each thing, square the unit. This is what it looks like. Does that make sense if I pronounce it like that? Not squaring individuals, squaring the whole item. Which will create a FOIL. Okay? This isn't a FLU, I'm sorry, you don't get to cheat, because it's not conjugates, right? Because it's plus plus. Okay, so go ahead, FOIL it, and see what you can get to. Okay, if you are a sucker for shortcuts, this is always the pattern. You're always going to get the first thing squared here and the last thing squared here. And in the middle, it's always going to double the multiplication. This will always double something in the middle, right? 4 root 50, 4 root 50, so it's now 8 root 50, it doubles. Okay? Okay, so root 25 was the first thing, so I'm going to simplify that to be a 5. And I can put those together, double them, so 8 root 50. And I'm going to change the root 100 to be 10, so plus 160. Okay, I have 2 more things left to do now for this. What can we do? So the first thing you probably would have done is put that together and something else, because this would be a reduction on a test.
Maybe root 50 can be reduced.
It can be reduced, yep. Root 50 can be, I'm going to call it, you can break it down. So you're thinking, what can I divide 50 by? 25 times 2. So on your test, I will ask you to do everything simplified, so collecting the same radicals together where possible and breaking down roots where possible. So leaving a root 50 will be a half point off because you didn't break it down. Okay? Have you noticed anything about like root 5 times root 5? Root 5 times root 5, did you notice how we just ended up as a 5? No, I can't put the 165 and 40 together because the 40 is attached to a root 2. So I can't put it with that because this is just a whole number, but this unit is how many root 2's I have. I have 40 root 2's. So I cannot put it with that. That's like putting something x, like 165 plus 40x. Like something like that. Are you going to put those together? No. Yeah. Because that's not like each other. You know what I mean? Okay, here's a question for you then. What is root 90 times root 90? 90. Because really what's going on when you times a root? Root 90 squared. That's what you're doing.
Cancel out.
Cancel out 90. Yep.